everyone. Welcome back to our last session in this block just before lunch. We have Ruth speaking now about tips and tricks, data science prototypes into production. Oh.
Thank you very much for coming. I am a mathematician and a cyclist. I have a PhD in a field of applied mathematics that's called operations research. And it's kind of funny, there's been several talks from this field at this conference, so I feel right at home. So in case you're not familiar with the field, it predates machine learning by about 50 years, and it is still solving all kinds of scheduling and logistics and routing problems and allocation problems all throughout many different industries. So where I work at the moment, I solve an allocation problem that's a kind of knapsack problem. So the mental model I want you to have, or the analogy for the knapsack problem, is you have a knapsack and it has a fixed volume and you want to fill it with objects and you want to maximize the value of the objects that you put in there. And for lots of these problems, it's not just the value of the items, but a whole lot of other things about the mix of items that you put into your knapsack that you want to optimize for. And where I work at the moment, I'm at a fintech startup. And so the application for what I'm doing is when mortgage lenders have these big trusts, so a big line of credit, so I don't know, $500 million, and what they do with that money is they write out mortgages to people like you and me, and now they've got a trust full of mortgages, and they've got a bunch of rules around the mix of mortgages that they're allowed to have in this trust. Because when someone gives you $500 million or $1 billion worth of credit, they're going to put some rules around it. And if you muck it up, we end up with what happened in the GFC. So there's an application team where I work, and they do a whole lot of other things to assist people do this trust management. And there are certain use cases when you've got a bunch of these trusts full of mortgages that you actually want to take out a bunch of mortgages and move them into another trust. And so this is where I have built an optimization job that solves this multi-dimensional knapsack problem for reallocating loans between trusts. And so you step through a wizard on our main application, and then they drop a message on an SQS queue, and they drop all of the inputs I'm going to need to run the code into an S3 bucket, and it wakes up the little isolated Python program that's sleeping in a Lambda, and then it runs the job. And this is the context for which I'm making this presentation, because there's a bunch of nice things that I've done for myself on this project that I think make this code base really nice to work with, and it's a bunch of tricks that I learned that they don't teach you when you're learning to be a mathematician, and they don't teach you when you're necessarily learning to be a data scientist. These are things that you learn when you're out in industry that make your code nice. And I thought it was kind of worth sharing. So there's, I think really deeply, again, I'm the only mathematician, the only person using Python at the place where I work. So I think really deeply about how am I going to make this testable? And when things go wrong, how do I turn that into something usable? And then I learned something this year, like a really sweet way to configure my logs. But like all data scientists, I start in a Jupyter notebook. I think it's a trap. Maybe I should change it so I've got the Star Wars meme, like, it's a trap. So your Jupyter notebook is a great place to start your prototyping, but you should wean yourself out of it as soon as you can. I was lucky enough to have several months and several refactors before I had to start talking to the application team about integrating this thing. And when you have to integrate this into production systems, your engineers will turn around probably at some point and go, what's the entry point of your application? And having a single entry point was a new idea for me. And what it means is, if you need to run this allocation job, there is a single function that you call, and it's called process allocation request. And there is a single, very structured request body that you have to send to it. It's a Pydantic data model. And that's your request body. So that is straight off the SQS queue, and it's validated straight out of the gate. And you will always get back an allocation result, which is also a data model. So now you have a single entry point. It will always take a well-structured request, and it will always give you a well-structured answer. And this put guardrails on how I think about my work. And then I think about how I'm going to make my work testable, because when this thing falls over, there's nobody else on the team who gets to fix it, and there's nobody else on my team whose fault it is, because it's just me. So the main places that I test is I test all the data that comes in, which I'm clearly in love with Pydantic data models because they're helping me do all of that. And then, because I'm the only person in the business who's doing really hard math, I have to check it for internal consistency. And these knapsack problems, because they've got all these different types of rules, and every time this job gets requested, you get a different combination of rules, I kind of have to check that each one of those rules is going to work in isolation or in combination. And then I check round trips. So here's how Pydantic helps me validate on ingest. The trust is one of the, what I consider the first-class citizens in my program. And I set it up with its attributes, and they can be as strongly or weakly typed as you want to define them. But it's nice because for something like metadata, like we're a startup, so the application team is always having to collect new information about different features to do with these trusts. So they've kind of got this amorphous blob that is called metadata. And one of the tricks that I use when I validate this sort of stuff is, instead of using like nested accesses, I'll either derive fields or rename them, or I'll use a computed field, and now I can access trust balance rather than like digging down a couple layers in metadata. And I do this in a bunch of different places. And then the other thing I do, again, because often the input data changes, so I get model validators which let me test if new fields are present. I like to log myself a warning, because sometimes the application team makes a change and they forgot to tell me, and this will just put something nice in my logs and I will catch it. The other thing that's really nice about model validators is when the data comes in, if there are certain relationships that need to hold, you can test them all here and you can fail really fast. And then, like I said, I have to check for internal consistency. So everything is coming into this application from the outside world in JSON blobs or CSV files. So I have like 1,800 lines worth of fixtures that look like these JSON blobs that come in all these different formats. And I have to test that I can evaluate them. And for any new model that I build, I have to test that I can grab this JSON blob, I can load it in and describe it to the new model in an appropriate way. Because when the job is actually called, it's any combination of these rules could show up. So I need to make sure that each one of them I can handle independently. It's also nice because the fixtures are reused everywhere. And because when the data structure changes, you update your fixtures, and then it's super easy to follow the bouncing ball for the test failed for this piece of code. You patch that piece of code, the tests start to pass, and it's just a really easy pattern to make your code really maintainable when the information from the outside world sometimes changes. So I think about, where am I doing these calculations? And there's some other nice ways you can add randomness, because I think static data sets are a trap. A lot of people are trying to get me to use hypothesis. I'm not that sophisticated yet. What I do instead is every time I run a test session, I will generate a random synthetic data set of loans and and it gives me some good wins. I have occasionally intermittently failing tests, which are super annoying, and I think this is one of those places where the property testing that you'd get out of Hypothesis would probably help you program better against those things. I also check my coverage report, but I am advised not to live or die by your coverage report. So my coverage is at 87%, and I'm really proud. This is for the optimizer, like the main package that I've written. And I sorted this by the number of missing lines because some of these gaps I can live with and some of them I can't. Like the second row here says that my utility models have 0% coverage, but the only place that utility models are used for is generating synthetic data sets for running a test session. So I can live with that. What I can't live with is low coverage in the evaluator. So I need to have a closer look. The evaluator is where I evaluate every single one of those rules. And so what I do is I pop this open and I look for patterns. And here's a really clear pattern. I've tested how my function behaves when the input is well formed, and I have no test coverage for does this thing fail nicely. And again, if you know that that's where your gaps are, it's pretty easy to make a pattern to cover it. Here was another pattern I found. I had no tests on my cloud I/O, so one Friday in my 20% time, I just worked out how to mock an AWS service, and that problem has gone away. The other big section of my testing, I guess, philosophy, is making sure that I've got tests that do the complete round trip. Because this whole thing is based on, I have a single entry point, which makes it a really nice way to collect failed requests. So failed requests normally come to me when my boss is testing the software and he's like, Ruth, it's broken. And I go and I scrape that request from the S3. And if it doesn't contain sensitive information, I will collect it in my set of failed requests. I will fix whatever bug he hit or put a validator in for whatever condition he created. And then every time my test suite runs, it'll go through all of those previously failed requests, and it'll make sure that fixed stays fixed. But when things fail, you got to do something with that. Because for an end user, if they clicked the magic button that said optimize, about which I've built my whole career, and nothing happens, then that's no good for anybody. It's not informative for my boss. It's not informative for our customers. And actually, it's not that helpful for me. So I've got some patterns around treating errors as information. And I often think, when I'm coding for this stuff, like, who needs to know? Like, who cares that this failed? Who is going to see this failure message? And how do I need to phrase that? So I made a class. It's a data class. Who would have guessed? And it's called informative errors. So when you get an allocation result, as you can see here, you get some information about the solver you invoked. If you're lucky, you get a full solution in your allocated loans. And if something went slightly sideways, then you might get a list in the error responses of these informative errors. And the thing that's fun about informative errors is that there is a description that is a string that the application team will always render to the user. So on the result page for the optimizer in our application, there is a panel that will print all of the descriptions from all of the error responses if you got them back from my program. So I have full control over what the end user sees, and that's really nice. And then within that structure, I also have the informative values, which are a little bit more for me, maybe for the people on the application team, but for anyone who gets to read my entertaining list of error responses, there's also some slightly more technical information. And this becomes my pattern. I'm going to try and execute a block of code. Maybe I'll catch an exception, or maybe I've got a match statement, and this is in the default case, what you actually get is I'll probably log myself a warning, and create one of these informative errors. And then you keep stepping through the optimizer. And then maybe you've got a collection of these informative errors. Maybe you had so many errors that we couldn't invoke the solver, and then the allocation result you're going to end up with is going to say that the solver status was not started, and that your allocated loans list is empty, and you're going to get all of the info in your error responses. I hope. And now I want to talk about logging. So I clearly care a lot about where information goes in my program. And it wasn't until I watched this guy's video that I kind of upped my game about how to catch those logs nicely. So this screen capture from his video is where he's explaining the structure of the Python logger. He's done the deep dive. It's apparently a very old part of the Python library, and it's not very well documented, and it's old-fashioned in the scale of Python. And so he's done this deep dive, and here he's explaining what happens when you create a log message, and then how you can create filters so you can obfuscate parts of your log messages if there's private information in them, and then how you can send them off to handlers so that when you invoke your program, you can choose which handlers are going to be active, and you can define what messages go where. And it's really nice. When I'm prototyping in Jupyter, I can send my logs off to a log file. And it's kind of an interesting idea because in Jupyter, I only want them to go to a log file, and I want them to go to a separate log file to my application logs. So when my application is running sequentially, I get those logs to go to two places. I get warnings and above to go to a console, and then I get info and above in a structured format to go to a rotating file handler, which is kind of nice. It was also kind of a nice way to impress some of my friends on the application team, because they're like, oh wow, you're making structured logs, that's so nice. So it's also a little bit of a flex, but this is how you invoke it. In one of the top cells in Jupyter, I will point it at the Jupyter config file, and then I use it in dict config. So that's how it's configured. Okay, so let me just go back 2 slides and say one more nice thing about this video. This has the perfect level of technical detail. It's got an activity that you can do while you're watching the video. It's got an extension activity to do after you've finished watching the video. And it's got the perfect level of good-natured sarcasm. So it's like one of the most entertaining videos I've seen this year. And so what it means for me now is that my application logs have their own configuration, and they all end up in one spot. When I'm in Jupyter, that has a separate configuration. Those logs come out in a different format and go to a different place. And then, in case you didn't already know, PyTest has got a cap log fixture, so you get control in there when you're running a test session about how your logs show up. And that's kind of it. I have done, on this particular project, a bunch of things I'm really proud of that make this code really nice to work with. And I've got this whole idea about anytime something fails, turn it into information. I mean, I don't think these are new concepts. Turn your errors into information because somebody cares, even if the only person that cares is you. And the testing that I do is the way to make sure that my code and me as a mathematician is doing something that's reliable and consistent, because I can't explain all the detail to anyone else at work. That's kind of why I'm here, because you guys get me. Thank you. And that data models are probably the nicest way that I've learned to have a really nice contract with the outside world. So thank you. You've been an absolutely marvelous audience.
Thank you. We have time for questions. Do we have any questions for Ruth? Just put your hand up.
Hi, it's Paul Leopardi here. Do you have any advice on how to mock things up? Because that seems to be the linchpin on how you go about trying to do something in PyTest and trying to understand exactly what the structure is of what you're trying to mock up and trying to make it behave like the real thing is like non-trivial.
Absolutely, and I spent a lot of time thinking about it. So testable code is good code. This is like you don't have to write your tests when you're writing your code. Controversial, I know, but you should think about if I have to create some functionality, what is the minimum set of data I need to shoot at this function in order to get an answer? And so this is why, for me, I ended up building tooling. Like I have a whole utility models. Like this whole module, its only job is to build a synthetic data set that I can use when I'm prototyping or when I am when I'm running my test suite. And like it's part of the minimum set of data that I require. And so there are some other tricks in using randomness as well. Like, because randomness doesn't benefit anyone. If you've got a highly deterministic system, then you probably don't need randomness in your test suite. But having some way to think about building up a set of fixtures that you can reuse in a bunch of places in your code, but structure your code in a way that it leans into that idea.
Really nice talk, some really great tools there. I've only deployed like servers and stuff to Lambda functions, and I've never deployed a simulation system to Lambda functions. Just curious if you've had any issues like getting the simulator to work on your local laptop, but then trying to get it work on the Lambda function.
I wouldn't call it a simulator so much as I'd call it an optimization, like an operations research solver. I think the biggest problem for me is at the moment, Lambda is some kind of slow, clunky, asleep piece of hardware. And I run all of my stuff locally on a pretty new MacBook, and it runs super fast. And I think one of the biggest problems I have is the difference in speed between my developer setup and the cloud setup. Like even on my deployment pipelines, the test suite takes 10 times longer to run. So those are my challenges, because I didn't actually have to build the infrastructure myself. I had an infrastructure engineer build the infrastructure, now I have to maintain it. But yeah, some of my problems sort of occur at the benchmarking and thinking about timeouts, because when you use a search algorithm, like I sometimes do, I actually have to estimate how long I think, or how many generations I can run this algorithm, or what the timeout should be given how much time I've chewed up in my Lambda already, and how much time I've got to go. And I guess that's one of the tricks. Which I haven't had to do before. I hadn't had to think about before. But I think the other part is when you start to have to worry about traffic. Like, if this becomes the hottest feature and everyone wants to use it, then the fact that it's currently living on a Lambda is going to be a giant problem. Or if it turns out that the requests that we're getting are way too big and we just need to run it on faster hardware, it's kind of the program itself is written in a nice enough way such that it's easily moved to other hardware. But yeah, you do have to worry about what are the limitations of this cloud widget I've chosen.
Yeah, it's excellent talk. Do you mind elaborating why you said like notebook is a trap?
Oh, Jupyter notebooks are a trap. They're a trap. So Python itself has that delightful feature of being dynamically typed. But at least when you're running a Python script, it will run sequentially. So something that you declared up here, if you change it to something else down here, it's kind of fine because the program will always run from the top to the bottom. But if you're doing the same kind of programming and you're changing your variables halfway through and you're just using duck typing, reusing variables down here doesn't necessarily mean in your Jupyter notebook, unless you're disciplined. Maybe you've got discipline. Actually, I saw your talk. You have the discipline not to fall in this trap. I know who you are. I think this is a trap for young players. If you use variables lower down, that you're actually reusing names from somewhere above because you're not forced to run those cells sequentially. It just multiplies all of the bad behaviors that you can fall into when you're using Python. Is that fair? I don't think that's what you're doing, though.
No, excellent. No, it's very useful. Thank you.
Hey, really great talk. I was just wondering what the actual user interface looks like for the end users and how you deal with CSV data if you got nested data structures for them to upload.
So the CSVs aren't nested. So we have data that comes in two ways. If we offline, I can show you what the interface looks like from the application team. Your opinions may vary. And I'm certainly not a front-end designer, right? So we have data that comes in two flavors. It's either JSON data structures, which can be nested, or it's tabular data, which comes to me as a CSV. And there were absolutely choices made as we planned the integration of this about whether or not my program would just have a direct API to the data as it's stored in the database, and it was decided that, at least at this early stage, the application would handle all of the packaging of the data into JSON files and CSV files and put them into an S3 bucket, and that was literally the only interaction point that the Python application would have with the outside world.
Thank you. I really enjoyed your talk. I felt very kindred kind of relationship with your setup being the only person kind of fighting for these things in your role. Do you think we should start a support group or something for the Orphan Programmer Outreach Society or something? I feel like it would be great.
I feel like outreach would be nice. I actually think that we're going to end up with an operations research outreach group because I can see at least 3 operations research practitioners in the room. I didn't expect to see so many of you here. But it's funny that you should say kind of funny, kind of joking, but kind of not, because let's just start a Slack. I'm on a Slack for women in testing, and it's this really nice group, and it's a bunch of women who work as quality engineers. Did you see that Brazilian quality engineer from Red Hat talk the other day? She's doing some ninja stuff, and she's not on that Slack group. That's an international Slack group of people who are, have these same feelings. I think I'm probably going to get kicked off, though, because all I will do is tell people to use pedantic data models. That's my bag.
Thank you so much for your talk. I was wondering if you ever got any pushback about the amount of testing you do, and if you did, how did you navigate those conversations?
I think sometimes I would get pushback about the time that I might take on a task. And the way that I deal with that, it's kind of cheeky. If you don't have the time to test your work, then take the person who's rushing you and try and explain to them what you're trying to do. And at the point that they go cross-eyed is the point at which you say, now this is why I have to make sure I've got a test that makes sure it's working, because otherwise how else would we know? And also these are combinatorial problems. So I need to take the time to test this one rule. I think of this like an atom, because by the time you send an entire optimization request, I've got 5 trusts. They each have 20 rules. And so now I've got 100 of these atoms in some weird combination, and I might have 100,000 loans. And this is all of a sudden a giant problem, because when you're at the stage of a full-scale problem, there is no way I can isolate the source of an error when I've got that much. But when we're talking about I'm building the next new rule, then you can convince someone that if I scale this up, it's impossible. But if you just give me a hot minute, we'll get this done, and it won't fall over. Or you can leave them sarcastic error messages. So remember that trap? Like, those descriptions go straight back to the customer. 80% of the time at the moment, my customer is the COO. And a lot of the time, he's put in test data. And so when I get the, Ruth, this is broken, and I realize that if I add a new validation test, I'm actually now going to provide a nice polite message back that says, oh, actually, you've got duplicate loan IDs. Here's the first 10. So there's the other way you deal with it. Add a new validation check, and let them read the polite message. Like, be polite, because they don't know they're doing it. They don't get math.
Okay, that's all the time we have left for questions. I would like to present Ruth with her official PyCon AU mug.
I'm so chuffed. Thank you.